No, that is not what we're talking about. What we are going to talk about is the enclosure I made for my Wanhao Duplicator i3. Well, more specifically, we're going to talk about the control box replacement I made for my Duplicator i3. What's important to notice here is the fact that I'm doing all this because my enclosure is meant to be universal. That means that one day, either I'm going to get rid of this guy, or I'm going to replace it with something else and keep this as a secondary one. Nonetheless, what I plan on doing is reusing this enclosure because it just works so great. It has perfect lighting, glass front, it has vents and cable management built in. There's just no reason to replace it. And with that in mind, I built this control box to do the exact same thing. The wiring on the inside has been made universal so that I can use it with any printer I decide to build in the future. The faceplate itself I designed and 3D printed, and I don't have to change it at all. All I do is unscrew the LCD out of the back, put in a new one for either RAMS 1.4, RAMS FD, or RADs, anything. All the LCDs are exact same size, so it doesn't matter. But the point being that I'll be able to reuse this. And also, what this allows me to do is get great cooling without having such loud fans that I can't even hear myself thinking. This enclosure itself has 2 fans on top, 2 in the back, one 120 millimeter one in the front, and, oh, I forgot to mention this. I'm using an ATX PSU on the inside, which I'll show you guys in a second. What that allows me to do is to draw all the power I need for the printer, the heated bed, and the Raspberry Pi, which is also in here at the moment. In a few seconds we'll get inside and I'll show you a bunch of stuff and what it can do and what it is designed to do, or at least that's what I plan on using it for. Well, let's pop the front open and see what we've got here. If I can get it unlocked, there we go. All right, let's see. This is 3D printed. All these guys are. We've got the Wanhao logo here. Got a skull to mark the kill switch. This will function as the emergency switch that I covered up here. It's too tiny. It's not universal on all the screens. They're moved side to side, and so I didn't want something there that I eventually get a different LCD and it no longer connects. And so I covered it up and replaced it with this. And what's great about this is that it controls the ATX power supply. And so if I press it, it shuts down power to everything. Except, of course, the Raspberry Pi. The Raspberry Pi I put on its own circuit, which means I can turn this on and off without doing anything to the Raspberry Pi. That'll allow me to go in, use the Raspberry Pi, pull stuff off it, add stuff to it, use it for something else other than 3D printing without having to ever turn on the 3D printer itself. These ports here and LEDs and stuff, they came with this case. I was going to remove them, but instead what I did was I did some rewiring on the inside to get the USBs working. One of these actually directly connects to the 3D printer. What this means is that if I ever need to go into Repetir Host, I no longer have to open up the case, disconnect the Raspberry Pi, connect to the PC and everything. Nope, I just connect a USB port here, goes directly to the printer. The other one, I did some rewiring again, and it's attached to the Raspberry Pi. And again, what that'll allow me to do is go in and troubleshoot or use the Raspberry Pi via USB without having to actually open this up and get to the Raspberry Pi. You may not be able to see it with the flash on, but let me see if I can show you guys how this functions. So I press this button, and now look at the LED. Lights up. The printer itself is not connected right now. I disconnected it. I'll show you guys that when it connects. This button here turns on and off the Raspberry Pi. And that'll be interesting to show you guys once we get inside also. This LED turns on when the whole printer is on. It's green, but you can't really tell here. These two are orange, and I couldn't actually find a function for them, so all I did was, instead of poking them out and have holes here and push out this button and get another hole down there, I connected them all up, and this is what it lets me do. They flash on and off when I press the button. So they work, but they don't actually do anything. Alright, I'll stop this video here, and then we'll jump inside. Take a look at what's going on in there. Alright, so this is the lid for the whole enclosure, and it's nice because it's got two fans built in there, but those fans have a dual purpose. They have LED lights built into them, which means that when this case is inside the enclosure, all I have to do is lift a little bit, and I'll be able to actually get some light in here inside the enclosure and see. Two more silent fans back there, a giant silent fan on the side of the ATX power supply, a 120 millimeter, very nice and silent fan here, and okay, let's go into the wiring. So, I'm not sure if you guys are familiar with how an ATX power supply works for a PC, but it doesn't actually turn on by itself. It has power running to it, but what you do need is the motherboard on a PC to tell it to turn on. And how it does that is by shorting out two wires against each other and keeping them shorted out as long as the computer is running. And it does that through software. Well, we don't have a motherboard for a PC here, and the multi-board is not capable of doing it by itself. So what I had to do is short those wires out. But first, let's take a look at why an ATX power supply is actually very useful in this case. It provides, through just one rail here, a bunch of different wires carrying different voltages, which are useful for a bunch of different stuff. Well, what I did was, unlike other people, because this is a very expensive unit, I didn't actually cut the wires on it. I got an extension, cut the top off of it, and used those wires to make my connections to that screw terminal. The screw terminal itself is nothing special. I made this little lid for it. I don't know if you guys can see it. It's got a little lightning bolt on it, just to remind myself not to stick my fingers in there and electrocute myself. But let's go through the wires, and so that I can give you guys a little deeper understanding of what's going on. Yellow on these rails is usually 12 volts, which is what we need to run our 3D printer, the multi-board, and the fans, the heated bed, and everything like that. And what I've done here is take 12 volts connected here, and that goes to the printer and the heated bed. Next to that, you see the purple line. The purple line carries 5 volts, and it's constantly on, whether or not those two lines I was talking about are shorted out. Why this is important is that that's the line that allows me to use the Raspberry Pi and have it on despite the fact that the rest of the ATX power supply is off. Next to that, we have another line, and that one is orange. I don't know if you guys can tell in the video or not, but orange also carries some voltage in it, and that being 3.3 volts. That I used to light up the LEDs that you saw in the front that did nothing but flash. Well, those LEDs came for another case, and they can carry that 3.3 volts, so I'm using them. Next to that, we have green. Green is the wire you need to short out against a black wire in order to turn on the PSU. And what I did there is short that out using the switches that you saw in the front. When I press that button, it shorts it out against the black line that's next to it. The line you see here is a red one, and I'm using that, as it carries 5 volts, to light up the LEDs that are in the switches. So again, yellow is 12 volts, purple carries 5 volts, but it's constant on. Orange carries 3.3 volts, and red carries 5 volts. All right. As you can see, I've soldered these, crimped these, and you may not be able to see them, but I've also hot glued them. What this allows me to do is, again, like I said, all these connections will be able to be used on different projects without me having to reconnect everything. These connections here are everything that's coming from the switches, from the Melty board, and the Pi, because the Pi is also powered from here. All right, let's just move back a little bit. All right, I have another line coming from the ATX. This is a PCIe line. Carries voltage, power management, cable management, comes all the way around, and this is something I really like. It is not exactly a fan controller. All it is a distribution. And what it allows me to do is split the power coming from that PCIe line and power as many fans as I like. So right now I only have the 3 that are actually in the case connected here, and the 2 that are on the lid are disconnected. And I put it this close to the front so that when I raise the lid, I can disconnect the fans that are connected to the lid and move the lid. Alright, the Melty board you can see right there. It's sitting in a case that allows it to be insulated from the case and any other thing that may come into contact with it, and that was important for me because I didn't want to screw the board into this case. Again, coming back to the fact that I want it to be removable so I can upgrade it. And so that board is hot glued in place. That will allow me to, if I do need to work on the Melty board itself, I can remove the case without ever having to touch the board itself and then work on it. Ooh, Raspberry Pi sitting on the side, mounted to the side of the case. All the USB cables that connected to everything, the splitters and things like that. The cable management here that you see are my own invention. I think I've seen a few other people use it after I showed it in another video. But these are just binder clips, the stuff that just goes on the outside of binders. And I've used it to manage all my cables. They're more stiff than the swivelly stuff that you can buy at the store, and so that these wires aren't just flopping down on the floor, they're going straight to where they need to go. I'm also using that for the fan wires here. Okay, I think that's everything on the inside. Let me show you guys what it looks like when the Melty is actually connected. Here comes the Melty board, it's on. Now, if you guys notice, the Pi is not on. That's because the other switch is not pushed in. Let's push it in. The Pi just came on. Let's turn it off. Turns off the Pi. None of this affects the printer itself. Let's turn on the Pi. Turn off the printer, Pi stays on, which is exactly what I wanted, to be able to use a Raspberry Pi without having to power on and off the whole thing. Another thing that was very important to me was to minimize sound as much as possible while getting maximum cooling. Now this thing has a nice big filter built in here so no dust goes in. All the other fans are silent. Let's turn them all on. All the fans are on. Let's see if you guys can hear when I put the camera in here. That's the ATX PSU. Those are the fans on the back. This is a big 120 millimeter fan that's blowing not only on the Pi but also the Melty board. And what's really nice about using these ATX power supplies is that they're silent. And the main reason for that being that these fans are thermally controlled. They only come on when it gets hot, as in usage on them goes up. And so this fan is running, but I can't hear it. Anyway, power management or cable management was very important in here because of the fact that I don't want things getting mixed up. There's the lid back on that. Again, I made that myself. The case for the Melty board, I've already put on Thingiverse. It's actually really nice the way I fixed it up. It is a remix, but I did clean it up. I gave it feet on the side so that you can attach it to different surfaces without having to attach the board itself to something. It also has spacers built into it so that the board itself is insulated. Oh, here's something else that I forgot to talk about. I got a longer LCD cable so that I can move the Melty board further away from the screen if I needed to, but I'm not sure if I'll actually do that. Well, I think that's all for now. I have the switch taken off. I had an extra switch built in, but as you can see, it works. I am getting a defective error on there, but that's because I don't have anything else connected to the printer. Anyway, I'm going to put this into the case, and then I will do another video showing you guys the whole thing, and let me know what you guys think. And have a good day.